As I said, we're trying to build up a library of useful functions. And we'll start off with a fairly hard one with the absolute value function. The next thing to put in our library, into our catalogue if you like, are what are known as the polynomial functions. Polynomial functions turn out to be the ones that we use the most, simply because they're the ones that are easiest to use. So a polynomial function of degree n, that's the maths speak. A polynomial function of degree n is one that's of this form here. That looks horrible. But what it's saying is, I've got a number times x to the n plus a number times x to the n minus 1 all the way down to a number. Where the n is a counting number, so it goes up to a degree like 1, 2, 3, 4, 5 or 6 or whatever. And these ai, these things are just constants, they're just numbers. And everything but an I should put in here should be non-zero. I probably should have put in here an is not equal to 0, but the others can be. Because if an was 0, then it would be a polynomial of degree n minus 1 rather than n. Now it turns out that we know an awful lot about the lower degree polynomial functions because we've been studying these under our guise of coordinate geometry in here. So, determine the domain and range of these polynomial functions. This first one here, f of x is equal to 1. So I've just got a naught is 1, all these are 0 here. So this is a polynomial function of degree 0. This is, because it's a naught x to the naught, if you like. X to the naught being 1. So this is a polynomial function of degree 0. And the graph is a horizontal line. We know that. And so it will look like everywhere that. So down there, there's my graph of y is equal to 1. Given that I know what the graph looks like, I can work out the domain and the range. It says for what values of x can I work out the function? Well, any value of x. So in here, the domain of our degree 0 polynomial is the set of all values, set of all real numbers. The range, there's only one y value ever used, so the range consists just of the number 1. That's the only number that the y value ever takes. So we know everything there is to know about polynomial functions of degree 0. The next one, I've got x to the power 1, so I've got all of the terms except these two. I've got these terms here, a naught and a1x. So this is a polynomial function of degree 1, x to the power 1. So this is a degree 1 polynomial function. Now the thing is, we recognise this. This is a linear function. Its graph will be a straight line. It will have a y-intercept of 3, and it will have a slope of 2. So if I go backwards here, it'll come down 2. So this will go something like that. There's the graph of that one. That's y, oh, I didn't mean to go up that high, you know. Y is equal to 2x plus 3. Sitting there. That's its graph. We can see its domain and range. We already knew what it would be. The domain says for what values of x can I calculate this function? And of course I can calculate 2x plus 3 no matter what value of x you give me, or alternatively here I can see no matter what value of x I choose, there's a point on the graph. So it's all real numbers. Likewise the range, doesn't matter what y value you give me, I can find an x value, a point associated with it. So this range will also be all real numbers. This one, part C, we've now moved up and we now have an x squared term. So this is a polynomial function of degree 2. So this one was a straight line. We know from last time that the graph of a polynomial or of a quadratic function is in fact a parabola. So the graph of this one is going to be a parabola. What do I know about that parabola? Well, firstly, I know that it's concave up because the coefficient of x squared is positive. So it's a concave up parabola. It passes through the y-axis at minus 3. So I know it goes through there. It has a y-intercept of minus 3. When I put x equal to 0, function x is equal to minus 3. It's got a y-intercept of minus 3. I guess the other thing that I know in here, let me just quickly scribble down the bottom. Here, function x is equal to x squared minus 2x minus 3. If I were to factorise that, I think here I get x minus 3, x plus 1 in there. X squared minus 3x plus an x. Might make that a 2. Yep, 3, got it right. Minus 3x, yeah, that's right. Because that'll give me minus 3x plus, it'll give me minus 3, yeah, that's right. So sorry, that's x minus 3 there. So its x-intercepts are x is equal to 3 and x is equal to minus 1. So I know it's concave up, it comes down through this point here, comes up like that. Now the only other thing I need to know is where the vertex is. And I think I said to you last time the vertex was at x is equal to negative b on 2a. Or alternatively, it'll be exactly halfway between these, sitting in here between that. So that's 1, 2, 3, 4, so it'll be at x equal to 1. And when x is equal to 1, I've got 1 minus 2 is minus 1, minus 1 is minus 3, so it's actually got a vertex down there at 1 minus 4. And so I can draw this parabola. I'm crap at drawing parabolas, but anyway, there's its graph there. So I'll say the vertex is at 1 minus 4, sitting there. And there is the graph of y is equal to x squared minus 2x minus 3. And having managed to sketch that graph, I can now tell you the domain. Well, look, I could tell you the domain without sketching it, because the domain is going to be all real numbers, because I can calculate that no matter what value of x you give me. And this is going to be true of every polynomial function. The domain is always all real numbers for polynomial functions. The range, however, here is a little bit different. Let me come over here and write the range. The range is going to be the set of y values such that y, so I need to come across there, that's minus 4. Y is bigger than minus 4. So such that y is greater than or equal to minus 4, because for all values greater than minus 4, there's a point associated on the function. So I would say to you that it's important that you are familiar with at least these first 3 orders of polynomial functions of degree 0, degree 1 and degree 2. When you get to 1110, they'll probably want you to be able to sketch and know about functions of degree 4, 3 and 4 maybe as well. Okay, but in this course, going up to polynomial function of degree 2 for a start is a good thing.